welcome to the session. In this session, we'll be discussing theory, all the important theory or concepts that are needed for clustering. In the next session, we will do problems with respect to clustering. So let's first understand what is cluster analysis. So let's say I have these are the data points I have. The dots are nothing but the data points. So let's say I have many data points which are unlabeled. So basically there are no labels, right? And they can belong to different they can have different attributes. So during clustering, what we do is we try to group the data points into clusters and try to make some kind of groups or clusters. The data points within a particular cluster have similarities, whereas data points of different clusters have different attributes. So basically, cluster analysis is a fundamental task in any of the unsupervised learning. So we have discussed supervised versus unsupervised. Since unsupervised learning, we do not have labels to the objects. So in such cases, clustering becomes a fundamental role. It plays a fundamental role. So basically, clusters, how they are formed is normally they are done using trial and error method, because we do not have any supervised here for the classification purpose. So the main feature is the objects inside the cluster. So let's say these data points are nothing but the objects. So the objects within a cluster are similar to each other, whereas objects of different clusters, they vary significantly from each other. So let's say cluster 2, the objects within the cluster 2, they're all very similar to each other, whereas objects of cluster 2 are very different from the objects of cluster 3. So let's say this is a figure A where it shows data points with two features. So let's say this is the given input data. On the x-axis I have the samples, and on the y-axis I have the values, and I have plotted the data points. So I will be grouping the clusters. After grouping the clusters, I can get something like which we show in the figure B. So probably the grouping is done here based upon the similarities between the values of the data points. Now, main difference between classification and clustering. So clustering is basically, as I said, it's mainly plays a major role or a fundamental task in unsupervised learning. So unsupervised learning and cluster formations are basically done by trial and error methods, because we do not have any supervisor. Whereas in classification, the supervised learning with the presence of a supervisor. The supervised learning is done with the presence of a supervisor to provide the training and the testing data. The second main difference is in clustering, you have unlabeled data. You have the data, but there is no labeling. We don't say that if suppose I want to classify between cancerous cells and non-cancerous cells, we do not have labels. So you just get the data. Whereas in classification, in the training data, you have labels. You have a set of cancerous cells, you have a set of data sets for non-cancerous cells where the labeling is there. The third difference is there is no prior knowledge. So in clustering, there is just information given. You are just given, let's say you are just given a data set of cancerous cells and data set of non-cancerous cells, but there is no information, there is no labeling of the data, there is no information about what kind of attributes it is. So there is no prior knowledge in clustering. Whereas in classification, the knowledge of the domain is a must. It's important to label the data set, say that this cell belongs to cancerous or this cell belongs to non-cancerous. It's important to have a knowledge of the domain. It's important to have labeling. So hence that is why clustering is basically a dynamic process, right? So during the running, you try to understand the attributes of the data sets and do the grouping of the data objects. So it's a dynamic process. Whereas in classification, the labeling is already done, right? So once it is done, we don't change it. So it's kind of a passive process. So what are the advantages of clustering versus disadvantages? Advantages are, so clustering algorithms can handle missing data. So suppose in your data there are missing data, it's fine, it can handle it. You have outliers that it can also be handled. Outliers in the sense, I have some data sets which are, like I said, like let's say these are some data sets, let's say they all belong to one cluster. So this can be an outlier. It's quite different. Outlier means the data set is quite different from the rest of the data sets. The second so even though there is an outlier, even though there is a mishandling missing data, cluster analysis works well. It can handle it. The second advantage is it can help classifiers in labeling the unlabeled data. So we can use clustering for classification when we have data which is unlabeled. Semi-supervised algorithms also use clustering analysis algorithms. We have discussed all this during the first few sessions of the machine learning sessions, supervised versus unsupervised versus semi-supervised. So even in semi-supervised, we use clustering algorithms to label the unlabeled data, because in semi-supervised you will have both. Some amount of data can be labeled, some amount of data can be unlabeled. So there you can use, for the unlabeled data, you can use clustering analysis. The third advantage of clustering is it's easy to explain. This clustering analysis algorithms easier to implement. It's not very clustering analysis implementation is not very complicated, can be easily done. Some basic algorithms are very easily implemented, and it is also one of the oldest technique which is used in statistics, and hence relatively easy to implement. The disadvantages of clustering algorithms are they're very sensitive to initializations and order of the input. The way you give the data, that becomes important. The ordering can be important, and often the number of clusters present in the data we have to specify. Most of the algorithms, we need to specify in advance how many clusters that you need to form. So that can be a disadvantage, as you can have kind of a bias and can affect the result. The third one is scaling is a problem, in the sense, suppose you have too much of data, right? You have too long data sets. You're trying to scale it to, suppose I have like millions of data set. I'm trying to bring it down to thousands. So that scaling can be a problem here. And the fourth one is designing a proximity measure for the given data can be an issue. So we will discuss what is proximity measure in the next few minutes. So basically designing proximity measures, especially when you are having huge data or when you have scaling issues, it can be a problem. So what are the applications? You can use clustering schemes for grouping based on, you can use mainly for this where we have customer buying patterns. So basically recommendation systems where depending upon what the customer is buying, you do the grouping. So that's nothing but clustering. The second one is profiling of customers based on the lifestyles. So this person is having a lifestyle where he's spending thousands of rupees, 5,000 rupees every month for his needs. So like that you can do profiling. You can use it for information retrieval applications. You can use for identifying groups of genes that influence a disease. You can use for identification of organs that are very similar in physiological functions. You can use for taxonomy, for namely making the taxonomy of animals or plants in biology. You can use clustering for purchasing, for analyzing the purchasing behavior and demography. You can use it for indexing the documents. You can use it for data compression. So these are all the various applications where you can, suppose you're doing a project, identify one of these and apply the clustering algorithm, and that becomes a simple project. So what are the challenges of clustering schemes? The first thing is a huge collection of data. So you have a very huge data and also have high dimensions. High dimensions in the sense, lot of features, lot of attributes. So that can be a problem for doing clustering. Scaling issues for such huge data. So scaling in the sense, you're trying to bring down your data from higher dimension to lower dimension, and then you do the clustering. So that may not perform well. Right, your algorithm may not perform well on high dimension data, and after you do a scaling also can be a problem. So algorithm may not work well. And also units. Suppose you have you're doing analysis, you're applying clustering let's say on something on the data objects where the weight is, some of the data objects are having weight in kgs, some of the data objects have the weight in pounds, then again clustering can become a problem. So you need to maintain identical units of data. And designing a proximity measure is also a big challenge. So let's see what is a proximity measure. So basically clustering, when we are applying clustering, the first thing that should come into mind is proximity measure. So proximity measure is where we try to find a measure. How do you find similarities and dissimilarity between the object, right? See, I am grouping the making clusters based upon the similarity, right? And also there should be dissimilarity between different clusters. Now how do you do it? So that measure is nothing but proximity measure. right? So similarity and dissimilarity are collectively known as proximity measures. And how do you find out? The question is, how do you do it? Mathematically, it's very simple. We use some distance measures in order to find a similarity or dissimilarity. Let's say I have two objects. There is one object I, there is one object j. So I find the distance between I and j, right? So that helps me to find the similarity and dissimilarity. So dissimilarity, as the word itself says, basically indicates how one object is different from another. So the distance between two objects, let's say I have I as one object, j as another object, the distance is denoted as d of ij. So what are the properties of distance measure? So one is the distance always has to be positive, or it can be zero. It cannot be negative. Suppose the distance is 0, so that means there is that the distance if the between the object to itself is 0, so that means they are in the same place. And suppose I am comparing two distances, right? Suppose I am comparing the distance from I to j to I. Definitely it is going to be same, so that means it is symmetric. Triangular inequality. Suppose I have a object which is located in a triangular location, then the distance from I to j is less than or equal to distance from I to k plus distance of k to j. So these are the properties of your distance measure. So let's now discuss about different proximity measures. So how can you find the distance between two objects? There are various mathematical measurements for measuring the distance from I to j, and these are the different ones. Let's see the formulas of each in one separately now. Let's first see Euclidean distance. See, Euclidean distance, very commonly used distance measure. It's also called as L2 norm. So basically it is a square root of the square difference between the coordinates of a pair of objects. So let's say I have two objects here, xi and xj, and they have the features so let's say some k features, right? So the Euclidean, this is the formula of the Euclidean distance. So distance between xi to xj is square root of xik minus xjk to the whole square and the summation of that, where k ranges from 1 to n. So that's why Euclidean distance is the square root of the square differences between the coordinates of a pair. So this is the formula of Euclidean distance, which you need to remember to do the problems. So what's the advantage of Euclidean distance is the distance will not change with the addition of new objects. You add new objects, the distance will not change. The disadvantage is if the unit changes, then definitely the value of this Euclidean distance will change drastically. Suppose I'm changing the units from millimeters to meters, so definitely the value will change. And also, since Euclidean distance involves square root and also since it involves square, so when you are applying this formula where I have data points in the range of thousands or let's say 10,000s, definitely there will be some amount of computational complexity in your algorithm, which may reduce the speed of your computation. So let's see another proximity measure. It's called as Manhattan's distance. It's also called as city block distance or boxcar or absolute value distance. This is also called as L1 norm or taxi cab. There's a lot of names for this, but the most common one is Manhattan distance. So the formula is very similar to Euclidean distance. If you observe, there is no square root and no square. If you compare this with Euclidean, there is no square root and there is no square. So basically it's the absolute value of difference, right? So therefore there is very less computational complexity involved here. The third one is Minkowski distance. This is also very famously used distance metrics. So this is the formula. So distance from xi to xk. What do you observe here is the difference is you take the difference and take it to the power of r to the power of 1 by r. So basically if you observe this formula, instead of r, if r is equal to 2, if you observe this formula, if I make r is equal to 2, it becomes a Euclidean distance. If I make r is equal to 1, it becomes a Manhattan distance. Right? See, if I make r is equal to 1, the formula is equal to the Manhattan's distance matrix, or also called as a city block distance metric. If I make r is equal to 2, what does it become? It becomes square root of the square of this distance, right? So that's Minkowski. And suppose the third one, if I make r is equal to infinity, there's also one more distance measure called Chebyshev distance. So it becomes equal to that. So Minkowski distance, just by varying the value of r, you can get the three different metrics. The fourth one is binary attributes. See, before we go into other things, we need to understand some kind of attributes, right? So let's say if I have to find the distance among binary objects, right? If I have to find the distance about binary objects means what? It will either have value 0 or 1, right? So let's say x and y are the objects, right? So either it can be having, these are the values that it can, 0 0 0 1 1 0 1 1, right? If I have x and y, these are the possible 4 values. So let's say a is the number of attributes where x is 0 and y is 0. B is the number of attributes where x is 0, y is 1. C is the number of attributes where x is 1 and y is 0, and D is for x is 1 and y is 1. So in such a case, you need to come up with a table like this, which we call it as a contingency table. So in cases of binary attributes, if you have to find the distance, this is how you have to come up with a table, right? So just write 0 1 0 1 for the two values x and y, and a, b, c, d are the values for these different values of x and y. So let's say the horizontal axis is y, the vertical axis is x. So this is how you get the a, b, c, d values. The next one is simple matching coefficient. This is another proximity measure which is used to find the ratio of number of matching attributes and the number of attributes. So the formula for SMC, in short it's called as SMC, is a plus d is divided by a plus b plus c plus d. So you write the contingency table, find all the values, and then just substitute. So this is a formula for SMC. You need to remember these formulas for doing the problems next. There's one more called as Jacquard coefficient. This is also another useful measure, and the formula is like this. These are all proximity measures for binary attributes. Okay, so for binary attributes, what are the different proximity measures we have is, one is simple matching coefficient, where it is a plus d divided by the total number of attributes, right? And the other one is Jacquard coefficient, where j is d divided by b plus c plus d. The one more is Hamming distance. Now, this is also very commonly used distance metrics. Normally where we use this is where we want to know the sequence of characters or for binary values, right? So basically this Hamming distance, it is used to indicate the number of positions at which the characters or the binary digits are different. So let's say take this example, right? So I have two data points x and y. So what is the Hamming distance between these two? This is just compare each bit, right? How many bits are different? So that would be the Hamming distance. So you can see that the first bit, this is 1 and 1, it is same. The second bit, it is 0 and 1, it is different. The third bit is also 1 and 0, it's different. So therefore the Hamming distance is 2. So basically it will measure the number of bits how many number of bits will vary. So basically Hamming distance is used to, basically we are using this for knowing the sequence of characters. So this is also used for binary variables only, where we are trying to find out the difference. So let's say there are two more examples. Let's see, wood and hood. So how many characters are varying? Only the first one. Therefore the Hamming distance is 1. Okay, the next one is categorical value. So till now we saw binary, with respect to binary variables, we had Hamming distance metric, we had Jacquard coefficient, we had simple matching coefficient. Now coming to categorical variables. So suppose I have categorical variables, in the sense the input can be a code or it can be a symbol. For example, to represent a gender, I will say code 1 is, let me say code 1 means female, code 0 means male. So how do you find the distance here, right? So how do you find the distance here is like this. So let's say I will say distance is 1 if both the values are not equal. Distance is 0 if both the values are same. So when we have categorical values, we can find the distance like this. If it is similar, let's get code. There's no particular, the rule is like this. If it is similar, let's say the distance is 0. If they're not similar, let's say that then the distance is 1. So in case of ordinal variables, so ordinal variables are nothing but categorical values only, but they have an inherent order. Here ordering is important. So let's say I have a job designation 1, 2, 3, where I mean that code 1 is at a higher designation as compared to code 2. Code 2 has a higher designation compared to 3. So what you observe here is this is categorical variable where the ordering is important. So let's say the designations are like this: clerk, supervisor, manager, and general manager. Clerk is 1, supervisor I will assign as 2, manager I will assign as 3, general manager where I will assign as 4. So how do you find the distance between the employee X who is a clerk and employee Y who is a manager is just take the difference, right, and divide it by n minus 1. So what is the position of X? That would be 4. Position of Y is 1. So it would be 4 minus 1 divided by 3. That would be the distance. Okay, so 3 by 3, that is 1. So answer in this case is 1. So basically it is used to represent, so this is how you find, right? Position of X is 1, position of Y is, let's say, manager, right, 3. So 1 minus 3, take the absolute value divided by total value, total number of values minus 1. So you get the distance as 0.66. Okay, so to measure the distance between for ordinal values, you can take this formula. So there's one more called as vector type distance measures, right? Vector type distance measure, this is very useful for text classification, where we use a very important metric. This is a very important metric which we call it as cosine similarity, where we can use cosine similarity is a metric. It's a metric, distance metric, where we use this to find the similarity between documents. So let's say that I have two documents which are having some kind of text. I want to find how many things are similar, right, between two documents irrespective of the size. Then I can go for cosine similarity. So why it is called as vector type is I am finding the similarity between two things irrespective of the size. As the name itself says, cosine similarity, that means I am going to find the cosine of the angle between the two vectors in a multi-dimensional space. So I am finding the cosine of the angle between two vectors. So let's say I have two vectors, I find the cosine angle between the two vectors, and this is the formula. So this is a formula for cosine similarity. This is a very commonly used metric. In many, it has lots of applications. You also use it for text classification. It's just one example. You can use cosine similarity in many cases. You can use it for even finding the similarities between images where some kind of pixel values are given. Even there you can use cosine similarity, especially for grayscale images or black and white images or binary images. We use cosine similarity, find the similarity. So the formula is, cosine similarity formula is, similarity between X and Y is X dot Y divided by modulus of X into modulus of Y. X dot Y is basically a dot product, so it is summation of I is equal to 1 to n xi into yi divided by square root of xi square into square root of yi square. So this is a formula of cosine similarity. This is also a very popular distance metric used from many years to find the similarity between two things. So as I said, the numeration is, the numerator is actually a dot product and the denominator is a product of the norms. We call this as a norm. So that's it. So in this session, I have covered most of the theory questions that can be asked in clustering. So next session, let's start with the problems. Thank you so much.